Any questions up until now? Okay, so we're going to use a concept to try to solve this called like bases, or similar bases, or common bases, something along those lines. What's the base right here? 8. The base right here is 16. Are they the exact same? No, they're not. But I'm going to play a little trick. This is clever, in my opinion. 8 can be written as 2 to the power of 3. Does that make sense? And 16 can be written as 2 to the power of 4. And so here's the trick. Rather than writing it as 8, I'm going to write it as 2 to the power of 3. But you know how there's already a power up there? What that means then from a math perspective is that we're going to have to FOIL the new 3 that we get with the exponent that was already there.
Mr. Cleaver, can you please come to the elevator lift on the east side of the building? Elevator lift on the east side of the building.
What will happen with the 16 is it's 2 to the power of 4. So the 4 becomes like a new exponent. But the problem is we already had an exponent there. So it's going to get multiplied. We're going to FOIL them into each other, basically. So here's what you'd have. You'd have 2 to the 9x minus 6. And we'd have 2 to the 4x plus 4. Let me know if I lose you on that step.
You FOIL both the exponents.
Does that make sense? Yeah. And then we're going to play a really clever trick. Yeah, now let's talk about why they can cancel. You can do various things to equations. For example, you can add 1 to both sides. That's mathematically valid. I mean, you guys would have learned that back in, I don't know, whenever you first learned algebra. You can times both sides by a number. You can square both sides of an equation. This seems kind of odd, but if you wanted to, you could take an equation and add a base to both sides of the equation. Does that make sense? Like, let's say I gave you something and I said that 2 equaled 1 plus 1. That's a valid statement, right? Well, if you wanted to, you could times both sides by 3. Is this still true? Yeah. This is 6. That's 2 times 3. That's still 6. If you wanted to, you could, this seems like an odd operation to do, but you could add a base to both sides. It would still be true. Does that make sense? So long as the bases are the same, obviously, right? So what we're doing is we're actually removing a base. We're just eliminating a base and saying, well, if this comes with a base of 2 and this comes with a base of 2, aren't they basically the same? So we don't need to write them anymore. That's the trick we just played. So now at this point here, you've got 9x minus 6. You've got 4x plus 4. If I want to solve, I'm going to suggest let's minus 4x from both sides. So you'd have 5x. Let's add 6 to both sides. Sorry, it's getting really low. What would you have? It would be equal to 10. You divide by 5. You divide by 5. X would be equal to 2. Does that make sense?
I feel like that was like an easy question. I think it's gonna get much harder.
Obviously, yeah. But like that's the basic like premise is to. This is not the only way you solve them, but it's a skill in your toolbox. I'm probably going to use that analogy a lot in our next section on trigonometry. Sometimes I like to think of math as like a toolbox, and there's a whole bunch of things inside: a hammer, a screwdriver, a saw, and it's your job to figure out based on the project you're given, which is the question you're given, what tools you possess in your brain that could be helpful in solving the question. Does that make sense? Not every single little trick that I show you will be useful in all situations. That's kind of where your challenge comes in, is figuring out, well, what can I do that's useful? Does that make sense? In theory, you could have, at this point in the question right here, you could have squared both sides. Is that mathematically valid? Sure. Is it useful? No. So why would you do it? Does that make sense? Okay, so just a quick slide here about solving. When you solve polynomial functions, which is kind of where we started, the basic premise is you want a factor. So I don't know what the factors of this guy are, but typically it means that like you're going to get, I don't know, x plus 1, x minus 2, x plus 3. And that means here x is going to be negative 1, it's going to be 2, it's going to be negative 3. Does that make sense? That's kind of how you solve a polynomial. More recently, we worked on solving radical functions. The key premise to radical functions is you have to square both sides. How do you deal with rational functions? Well, you need common denominators. This guy right here does not have common denominators. So what I could do is I could do an x plus 2 over an x plus 2.
Olivia Bond, can you please come to the office? Olivia Bond, please come to the office.
So similarly, if you have exponential functions, one of the tools that hopefully you'll be able to work on over the next little while is try to get like bases. Try to make it so the bases are the same. So let's try some more examples. Oh, one more slide before I get to more examples. Would everybody be capable of trying to graph this in your graphing calculator to solve the? Or should I show that? You know what? Let's just take a minute to do it anyways. Okay, grab a graphing calculator. Let's just make sure everybody is clear as to how you could solve this same thing by graphing. What was the equation? One of them was 8 to the power of bracket 3x minus 2. And the other one was 16 to the power of bracket x plus 1. That makes sense so far? I'm making each half of the equation equal to a graph. If I do zoom 6, there's a decent chance I won't really see much. One of the reasons why I'm not going to see very much is this is 8 to the power. This is 16 to the power. These graphs are going to take off very quickly. And where they cross is actually going to be very, very high up. So I probably need to change my window so that my y maximum is considerably higher. So I'm going to go to 10,000. Just to leave lots of room. You may not see the graph very well now that it's going to 10,000. I guess that wasn't bad. They cross somewhere in there, right? I don't actually have to have the greatest picture of this, but hopefully you can see they're going to cross somewhere in there. Second, calculate the intersect. Come on, calculator. Anybody else able to get this as well? I threw a picture of it into the notes there for you. Which is the important number, the x1 or the y1? Yeah, because our goal for this equation was to solve for x. Yeah. So x was 2. Does that make sense? Pretty much without fail, well, I shouldn't say that. You should be able to, in a lot of questions, if you can't solve it algebraically, you should be able to just take two equations and find where they cross. Now that we have some knowledge of what exponential graphs look like. That being said, I've discovered, and this is my, 8th year of teaching now, diploma writers are fantastic at writing questions that try to prevent you from using your graphing calculator. So I want you to have more skills than that. If you like my toolbox analogy, it would be like I can fasten things with duct tape pretty much all the time. But it wouldn't hurt to know how to use a hammer and nails once in a while too. Does that make sense? And so if I, as a teacher, only ever showed you how to use your graphing calculator, it will work a lot of times. But I guarantee you, they will find questions where you really can't use your graphing calculator, and then you're kind of hooked. So that's kind of the point behind today's lesson. Let's work on practicing some algebra skills in case they're useful somewhere. So let's try another example then. Let's say you're asked to solve this. If they give you a question like this, in theory, you could probably just type it in your graphing calculator. It would work. Another possibility, by the way, if it was multiple choice, you could take all 4 of the multiple choice answers and guess and check them. And that's not actually a bad strategy sometimes. But if you absolutely needed to use some algebra skills, we should practice those too. So, like bases. 27. Can we write 27 as like something that involves a base of some kind?
3.
Fantastic. It's 3 to the 3 is what 27 is. 1 over 9 is a trickier one. Anybody? Well done, Brad. It's 3 to the negative 2. Let's talk through that, though, just in case you didn't intuitively pick up on that. What does a negative exponent mean?
1.
1 over, yeah. A negative exponent means it's 1 over top of 3 to the 2. And then hopefully you guys know that 3 squared is 3 times 3 is 9. So I can't give you like a, for sure this is, you have to have a little bit of problem solving skills to be able to recognize that 1 over 9 can be a common base. But now I can write it like this. 3 to the 3, that'll FOIL the x plus 3. And 1 over 9 is 3 to the minus 2, and that'll FOIL the 2x minus 5. What's the next step? You can actually probably combine 2 steps if you wanted to. You do need to FOIL that exponent stuff, but I guess in the exact same step if you wanted to. The nifty thing that happens here is that these 3's essentially cancel. You're removing a base from both sides. Can I do a quick aside before that, though? Let's say you have 3 to the 3, and it equals 3 to the 2 plus 7. Can I cancel these 3's? With that 7 there, no, I cannot. Okay. Let's say that it was 3 to the 3 equals 3 to the 2 plus 3 to the x. Actually, no. There is going to be a way that we can put these ones together, but the only way this is going to be valid is if you have a base to an exponent equals a base to an exponent, purely that, then you can cancel those bases. Put a plus or minus sign in between, put a multiply sign in between, that's going to screw things up. So next week I'm going to show you guys some more tricks to add to your toolbox. Does that make sense, though, in terms of when it would be valid to remove bases? Basically, you have to have an equal sign and just a single base on either side of the equal sign, and that would be valid. I'm guessing some of you guys have probably finished the question by now, aren't you? You'll have 3x plus 9. You'll have minus 4x plus 10. So you'll have 7x equals 1. Anybody get 1 over 7 for x? Awesome. Sound good? Oh, let's try another one. Okay, this one here kind of goes directly to what I just kind of suggested. We have to be really careful before we cancel bases. The only time we can actually cancel those like bases is if you have a single base on the left-hand side and a single base on the right-hand side. And before I even start this question, hopefully you guys can see there's a problem on the left-hand side because I've got an 8 and a 16 with the divided by sign. So we need to use other skills to help us get to a point so that we can cancel. Does that make sense? That being said, our first step is actually the same as it has been in the last 2 questions. Let's work on some bases here. Hopefully 8, 16, and 32 all kind of like pop at you. And you go, hey, hang on, there's a common base here. Common base would be 2. So 8 is really 2 to the 3. And then you still have x plus 6 there. 32 is 2 to the 5. And I skipped this guy, I guess. This one is 2 to the 4. That's 2x minus 1. You guys all okay on that stuff? Can I just hack all the 2's off? Not yet. I will. We will. I promise that's kind of the point here. But we have to combine the left-hand side 2's. And to do that, I want to remind you of a slide. It's going to take me a while to go all the way back here. But we actually started the day with this yesterday. Too far. It had a whole bunch of previously learned exponent rules. Let me just erase all the mess that's on here. One of these exponent rules will help us. Any thoughts? This one right,
The quotient law.
yeah, the quotient law is the one that will help us. This one right here. You guys see how we kind of have something similar? In the quotient law, the way it works is that if you have a base to an x and a base to a y, they have to be the same base, by the way. The way it works is that you can have a single base, you have to subtract the two exponents.
So
Okay, so back to where we're at here. Do we have a common base? Sure. Are they being divided? Okay. So dividing means write a single base of 2 and take your exponents and subtract them. So it's going to be 3 bracket x plus 6 minus 4 bracket 2x minus 1. Does that make sense? I like the toolbox analogy. I'll probably use it for the next little while. That skill we just did there, not exactly a grade 12 skill. Like there is no outcome that says students need to know how to multiply and divide exponents. It's one of those things where whenever you learn how to do that, grade 9 or grade 10, like you still have to know how to do that because it's useful in solving the question. So now I can cancel these 2's though. So. Okay, let's expand. You're going to get 3x plus 18. You're going to have minus 8x. And then don't forget this minus right here. This minus 4 and this minus 1 makes it plus 4. And it equals 15x minus 20. And now it's just a linear equation. So isolate for x. So I'm going to minus 15x to this side. I think it's minus 20x on that side. And then I need to minus 18 from both sides, and I need to minus 4 from both sides. So that's minus 44, I think. For 10 and 22. Which would be 11 over 5. Anybody else get that? Or did I screw it up? Does that make sense what I did? I didn't say it all out loud, but I got a 20 on one side and a 44 on the other. Anybody else get that one? Shoot, you guys are giving me funny looks.
I got 21. Or like 2.1, I guess.
Yeah, I got 2.1 as well.
What is 11 over 5? Is it 2.1?
No.
Okay, so I
Your number got
42 equals
divided by
40.
42, eh?
Equals 20.
You know what? That makes sense actually looking back here. 20, 18, and 4. Yeah, this should have been 42. Okay, so then reducing 42 and 20 would be 21 over 10, which would be 2.1. Okay, now I have what you guys have? Okay. Minus the fact that I screwed up math in my head. Does that make sense though, how to solve it? Okay. Just, I say this to my grade 11s a lot right now. Don't make dumb mistakes. If you can avoid making dumb mistakes, it helps your marks a lot. Questions so far? Okay, new challenge then. Throw them with word problems. Like I said, this is probably going to be the bane of your existence for the next little while. I find it frustrating. They're not easy. Because you have to do exactly what we just did there, except rather than someone giving you an equation, you have to make your own equation, which sucks. Because if you can't make your own equation, then the whole thing is going to fall apart. So, let's try an example. A bacteria culture starts with 3,000 bacteria. Stop. That's useful information right off the bat. Yesterday I showed you guys the idea that we can write an equation as y equals a times b to the x. That's usually kind of like a generic way of starting an equation. If it starts with 3,000 bacteria, where's that 3,000 go? It's the a value. Yeah. So I can say this is y equals 3,000. We're starting with 3,000. Okay, keep reading. After 3 hours. What does that mean?
Like that's how much.
I guess that's how long it's been. I don't actually, let's actually leave that for a bit here. Maybe it's better to use that number later. It then says the estimated count is 48,000. Where does that number go?
Why?
Good, yeah, it's the y value. Eventually, 3,000 will turn into 48,000. There's actually one more number that's given to us that's kind of subtle. It says that the bacteria are doubling.
Would be excellent.
Well, it means the base is 2. Does that make sense? Because what's going to happen is our bacteria are doubling. Here's our problem. We don't actually know how long it takes for them to double. Last day, when we came across this problem, we wrote it as like 2 to the x over 5. You guys remember doing that yesterday? And the 5 meant that if 5 hours had passed, then it would double. Today's issue is that we actually don't know how long it takes for them to double, but we know how long it has been. And so this is going to be a little different. This is actually going to be 3 over x. The top of our fraction means it has been 3 hours. And the bottom of our fraction is we don't actually know how long it's going to take for doubling to occur. It could double every 10 minutes. It could double every 5 days. So I threw a little box in the corner here. If this helps you, at least at first, whenever you do this little exponent that's a fraction, the top number is the total time. I should even put another word here. Elapsed. Elapsed. What's that?
PV4.
Ah.
Elapsed.
There you go. You're having a hard morning so far. Does that make sense? Total time elapsed is like the top number, and then the bottom number is how long it actually takes to double or triple or something like that. So here's our equation. So far, so good. I would say that this is the most frustrating part because you have to be able to actually write this equation properly. Now we have to be able to solve it. Now you do have a couple options for solving. If you need to, throw it in your graphing calculator and you can graph it to solve. But I'd recommend we should work on other skills. So if you get a question like this and you want to solve it algebraically, this 2 right here already is kind of a base. I have a problem though. This number 3,000 right here. This 3,000 and this 2 cannot multiply together. The reason why is that this 3,000 is going to the power of 1, and this 2 is going to the power of 3 over x. And one of them has an exponent, the other one does not. So the most common mistakes kids make when trying to solve is they try to make it 6,000 to the 3 over x. And they say, let's make the 3,000 times by the 2. That is not valid. Does that make sense? That's what we do. We actually have to divide the 3,000 away from the other side. So someone help me out here. 48,000 divided by 3,000. Good. Now I've made the question very purposefully 2 and 16. Hopefully you kind of recognize, hey, hang on a sec. 16 is, I'm running out of room here. 2 to the 4. So what you're left with is 4 equals 3 over x. Sorry that I'm running out of room there. To solve for x then, you should take x and times it up to the other side, make it 4x equals 3, and then divide away the 4. So x is 3/4. So what does this mean then? Back to the context of our question. You start with 3,000 bacteria, and eventually you hit 48,000. So it means that you've doubled this quite a few times. It says it's been 3 hours. How long does it take for the bacteria to double? 45 minutes, basically, 3/4 of an hour. Every 45 minutes, this thing should double. So after 45 minutes, it would be up to 6,000. After an hour and a half, it would be up to 12,000. After 2¼ hours, it would be up to 24,000. And then after 3 hours, it's now finally up to 48,000. Does that make sense? Let's try another one. This one involves half-life kind of ideas. So for any of you guys who took my physics class, there's kind of some similar concepts here. We're going to use some radioactive iodide. And iodide has what's called a half-life of 8.2 days. So to start beginning writing this equation here, I could say that things get cut in half over and over again. That's your base. And it gets cut in half every 8.2 days. This time, that means that the bottom of the fraction is 8.2 days. We don't know how much time has elapsed, but we know that every 8.2 days it gets cut in half. That's really loud. I need a few more numbers. I need a number to go here and a number to go here.
0.25 and 1.
That's fantastic. Yeah, I would start with a 1 right here and a 0.25 here. Let's talk through why. Actually, you want to try to explain why? You have an answer right.
Because I remember it from last year.
Fair enough. Okay, so let me try then. What are you starting with right here? Well, treat it like a percentage. You're starting with 100%. Does that make sense? You're starting with 100%. And by the time you're done, you only get 25% left. You could have then put the numbers 125 here, or you could put the numbers 1 and 0.25 here. Does that make sense? So this is what you start, and this is what you finish with. And what we do not know is we do not know how long, like the T on the top right here, we don't know how long it's going to take to get to that point. So this 1 right here, we don't really need to write though, do we? So maybe I can change it like this. This is 1/4, because that's 0.25. This is 1/2, and it's x over 8.2. Can I find a way to do a common base now?
It's going to be like with the negative.
Good. 1/2 is 2 to the negative 1. What about 4? Well done, Jana. Yeah. 4 is 2 squared, so 2 to the 2. But since it's on the bottom, it's now 2 to the negative 2. That's how we get it going. We're now to the place where we're going to work out pretty good. The 2's can cancel. And what you have is negative 2 equals negative 1 with an x times, well, x over 8.2. So how do you get the x by itself? I mean, I don't know. I'm going to make both of those positive, and then I'm going to times the 8.2 to the other side. So 16.4 equals x. That makes sense? So let's just go back to the question, see if that fits. If it's been 16.4 days, say this number was 16.4. 16.4 divided by 8.2 means that you should cut all of this stuff in half twice. So if you started at 100 and you cut it in half once, you'd be down to 50. And if you cut it in half a second time, 50 cut in half again would be down to 25, which is what it said it should be. That makes sense?
Yes.
Yes.
Okay, good. Sorry, just give me some feedback. Okay, one last one then. This is the last one, right?
Yeah.
Okay, so we worked on this skill yesterday. I've only, just so you guys know, I've only seen them give this question like once since I've been a teacher, where they make you use data in your calculator. but I still, like, my goal is to prepare for as much as I can. So, do you guys remember how to type this sort of stuff into your graphing calculator from yesterday? Okay, so stat, edit. Can I show you guys a quick little trick? Rather than getting rid of all this data here by pressing delete over and over again, you can go up to L1. Don't press delete though. Because what delete does if you press that is it actually literally removes the L1 up here. And we don't want that. Press clear. And then press enter.
What happens if you delete L1?
Okay, so just in case you do that and you press delete there, literally L1 is now gone. See what I mean? And now there is no L1. Like there's L2, 3, 4, 5, and 6. And L1 in the slot right here is now missing. So there is a way to fix that. Up here at the top here, you should go second 1, and then you're renaming it L1. And if you press enter, then L1 will show back up again.
Just right at the back.
But now it's the back. So what I do in this case here is I just delete everything. And then I rename everything from scratch. So I go second L1, second L2. By the way, it actually might re-bring the data with it. You guys see how I brought L2 back up? And then like there's now data with it. So to get rid of that data, don't press delete, press clear. And it'll get rid of all that data for you. Grab my order too. Thanks, guys. Okay, so hopefully you guys are ahead of me on this even. 0, 2, 4, 6, and 8. And then the other column you want 1097, 1156, 1362, 1789, and 2627. Make sure that your two columns are of equal length. Adriana, you had this yesterday. Did it say dimension mismatch? Is that the error it came up with? If your calculator errors and it says dimension mismatch, that's probably where your problem is that one of your columns is longer than the other one. So, okay, other things you need to do. You need to go back to your y equals and get rid of all of the old equations. We don't want them. And you need to go back up and you need to turn on plot number 1. If you don't turn a plot on, it won't show you data. Then I'd recommend go to your window and change your window size. I'm currently going from -10 to 10. I think I should go from 0 to, I don't know, maybe, it's asking me when it reaches 5600. So 5600, I'm guessing it's going to be 50 years maybe should be enough to make that happen. And then for the others, maybe I'll go from 1000 up to 6000. I don't really care what you pick for your window size, but just make sure that when you get a graph that you got some points sitting in there like that, like I did. Does that work? Then go to stat, over to calculate. 0 is exponential regression, and then just this depends on your calculator. You need L1 and L2 if it doesn't default to those ones. And then you need to tell it where to put the equation when you're done. And so to find that one, it's under vars for variables, which is right next to clear. You go over and find a y variable. We always work with functions, and I could care less which one of these you pick. You just need to pick a y variable, so pick the first one. Press enter. And if you go to your y equals screen, there should now be an equation sitting in there for you. And if you go to your graph, hopefully the line will go roughly through those points. It'll do its best to try to go through most of them. It's kind of like when I make you guys in science draw like a line of best fit through things. There's a chance that it won't go through all of the points, and so you try to make it go through as many as you can. So that's what your calculator just did. So last thing, we want to find where this equals 5600. And we'll intersect to find where it equals. So we really can't do this one algebraically. but using my graph here, it looks like it intersects at 15.94 and 5600. I've seen this before. I actually give this question on my tests here. I might ask you what year this will occur in, and then I make a numeric response. So it doesn't occur in year 15. What year does it occur in?
2010.
Yeah, it said this was from 1995. So year 0 is 1995. So take 1995 and add 15.94. So yeah, 2010, 94. What year did this happen in though? 2010 or 2011? It actually happened in the year 2010. It just happened in like December of 2010. Does that make sense? This might be one example where don't round. Like make sure you're really careful when you're reading the problem solving question, because now if it said to the nearest year or something like that and they suggested you should round, yeah, then make it 2011. But technically this happened in the year 2010, but like December of 2010. That was my last one, right? Okay, so summary of what we talked about today. Math sucks, and it's hard because it's very open-ended, and I think of it as a collection of skills, I guess. One of the skills I need you guys to possess then is, do you know what exponential graphs look like? Do you understand how to move them all over the place by stretching them and sliding them and flipping them? Okay. Because then based on that, you can solve things if you know what the graphs look like just using your graphing calculator. And that's a worthwhile skill to have. But another worthwhile skill is being able to recognize when they have common bases, because that can help you solve them algebraically. There's only one problem. What if they don't have common bases? What if you were given the question, like, let's make one up. What if it was 2 to the x equals 7 to the 3x plus 1? It's not really going to work. Now, you still can make y1 equal this and y2 equal this. That'll still work. But algebraically, I actually need to show you another skill later on. So that's where logarithms are going to come in next week. So, but my hope is that this at least gives you some algebraic skills for solving questions. So, do you guys have your assignment in front of you? Number 5, the newest one. You can't solve every question yet, and anything that you see logs, leave until after tomorrow, because tomorrow we're going to talk about what logarithms look like. But if you can find the assignment, number 3C is the question you guys should now be able to solve. You guys see 3C there? It's 5 to the x plus 7 and equals 5 to the 4 bracket x minus 3.
Why are you putting physics in math?
What was that?
I said, why are you putting physics in math?
You mean like the word problems? Oh, because you're going to get a word problem. I know. So, anyways, on 3C though, you guys can probably see if you have it in front of you that the 5s would cancel. So that's pretty much the new skill we've added. That and, I mean, like Taylor just pointed out, 4, 5, 6, 7, 8, and 9 are all word problems. Like most of what I need you guys to be able to focus on is probably, can you solve a word problem? Because you're going to get one, at least. Okay, I'm done. I've talked for way too much. You guys have questions? No, okay. Take 5, and then you guys can have whatever we got left to work on stuff, I guess. Cool. Oh, by the way, here's the textbook pages in case you care.